Hello everyone and welcome back. This is a new section in our class Projects in Linux by Eduonix. My name is Ahmed, and in this section we are going to cover two of the most commonly used activities on Linux, which are the backup and streaming. So let's get started. So what to expect from a backup tool, or when to consider a backup tool to be an efficient one. Any backup solution should roughly provide the following features. This is the least acceptable features that any backup tool you use, whether it was native or a third-party one, should provide. First, it should provide full and incremental backups. The difference between full and incremental, as you probably already know, is that a full backup may take the whole set of files and directories from your source paths or from your source media to the destination media, whether that was on a tape or on a CD-ROM or on a network drive, whatever your target destination was. The thing is, it takes the whole thing to the destination. While the incremental backup, on the other hand, takes only the files that has been changed since the date of the last backup. So, for example, if you took a backup today, which is, at the time of this recording, the 22nd of December 2017, and then 1 week from now, perhaps at the start of the new year, you decided that you want to take another backup, an incremental backup will only care about the files and directories that have changed since this day, since the 22nd of December. The second feature is that a backup tool, a decent backup tool, should provide file permissions and ownership preservation. This means that if you take a backup of files that were owned by some user, for example X, and you want to restore those files back on the same system, files that have been owned by user X should remain owned by the same user. Ownership should not change. For example, some tools or some methods, when you copy a file, it changes the ownership of this file to be the one of the user that copied it. So for example, if I am logged in as root and I copied a file that is owned by user John Doe, for example, to another directory, I may find that the file has changed its ownership to be owned by root, which will of course cause problems. So a backup tool must provide file permission and ownership. Of course, file permissions is also something that can be changed depending on the configuration that you have on your Linux box. So a backup tool must retain the ownership and the file permissions. And last, the ability to be automated. Backups typically take place at night. It takes place when the system is least used, so that it does not create any headache or any overutilization on your resources. So a backup is typically taken in the time where the system is least utilized, and this is typically after midnight. So instead of having some personnel staying up at night only to take the backup, the process should be automated as much as possible so that you provide the maximum efficiency, accuracy, and the least possible human error. So in this section, we are going to discuss a native tool in Linux. We are not going to install any third-party tools. And that is my personal philosophy, which is that whenever you have a Linux tool that does the job and that is efficient enough for you, do not use a third-party tool. That is because native tools enjoy support from the vendor. So in our example, we have Rsync, which is native to major Linux distributions. You will enjoy support from the vendor, whether it was Red Hat or Ubuntu or CentOS, whatever. The company that produced the distro will give you support. And if any conflict happens between this tool and any other library or application on the system, you will go to the same vendor, you will go to the same place. However, if you have a third-party tool and this tool caused some problems, you may return to the vendor of this tool, but if there is some conflict between it and between a library on a system or a system file, for example, you may find yourself going back and forth between the vendor of the third-party tool and the vendor of the operating system. And believe me, from a personal experience, this is a big waste of time. So the end line is, if you have a Linux tool that does the job, a native Linux tool, please use it instead of installing third-party ones. So in our case, we have Rsync. Rsync is a native Linux tool, as we have just mentioned. It can be deployed from the official repository. So it supports incremental and full backups. It also has the ability to transfer your files over SSH. This makes it highly secure. SSH, as you probably know, is short for Secure Shell, and it is a way of communicating with remote Linux machines over the SSL secure protocol. All your data is encrypted between your source and destination machines. So that is a big plus for Rsync. And finally, it can be automated via cron jobs to run in unattended mode. So you can run Rsync on a periodic basis to take full or incremental backups of your systems, as we are going to see later in the lab. So in the coming lesson, we are going to start by installing Rsync if it is not already installed on our systems, and we are going to explore the different options that can be used to take backup of your files and directories. So until then, take care. Alright, welcome back. In this lesson, we are going to start talking about Rsync. Rsync, as we mentioned in the previous lesson, is a native Linux tool that is used for various file-related operations. It basically transfers files and directories from one place to another, whether that place was on your local file system, so it's gonna move it locally from one place to another on your same machine, or it can move your files and directories, or technically speaking, copies them from your local machine to a remote one, or from a remote one to your local machine. Let's have a look. So for the purposes of this demonstration, I am going to download a web application from this GitHub repository. I found it online. I'm gonna download it. Okay, Git is not installed. Let's install it quickly. Of course, if you don't know about Git, it is a very, very famous version control system. I'm going to download it here in order to be able to use it. And I'm going to clone, using Git, I'm going to clone this web application. The reason I'm going to do this is that it will provide some files for us to work with using Rsync. This is just to demonstrate that, for example, maybe you're working with a web application, maybe you are a web developer and you want to back up your files on a periodic basis, and this is one of the most common uses of Rsync and backup systems in general. Okay, let's clear the screen and again let's download or clone the web application. Okay, here we go. It's called simple-php-website. Let's get inside, have a look quickly at the files that we have. Okay, we have a number of files. Suppose that this is your web application and you want to have a backup of this directory containing your web application files. So the first thing we need to ensure or to confirm is that we do have the Rsync itself installed. Rsync is spelled like this, R-S-Y-N-C. So I'm gonna use I'm gonna use apt-get install to install it. If you are on a CentOS system or a Red Hat based system, this is of course yum install Rsync. Okay, now I have Rsync installed on my system. Now let's say that I need to transfer the files inside this directory, simple PHP website. Let's say that, let's create a new directory on my system and let's call it backup. Let's put it on my desktop, for example. Okay, this is the backup directory, okay, and I need to transfer the files using Rsync. So I'm gonna type Rsync just like that, and then I'm gonna type the source and the destination. So the source is simple PHP website, the destination is desktop backup. Okay, if I use Rsync like this, and notice here a very, very important usage of Rsync, the slash. The slash at the end of the source or the destination defines a lot of the behavior that Rsync is going to follow. Let's see how. If I added a slash at the end of the source, this means that Rsync is going to copy the files inside the directory. So it's not going to create a directory that is called simple-php-website. Rather, it is going to copy just the files that are inside this directory. Okay, so let's see what happens if I used Rsync just like that. And I could also add -v for verbose. -r. I can just append it to the options. V, as we have just mentioned, is for verbose, which will give you an output detailing what's currently being copied. And R is for recursive, that is to take all the directories and files that happen to be under simple-php-website. Okay. Let's also add a Z. If you added a Z or a Z here, if you add a Z, this means that Rsync is going to compress the files while they are being copied. This may not be of a big difference if you are copying files locally on your file system, as we are doing now, but they might be of great advantage if you are copying those files over the network, especially if you are uploading them to a remote website, for example, on some web server that is located even in a different region than the one that you are currently in. It will prove to be very efficient because it's going to compress the files before transferring them, and on the destination those files are going to be decompressed, so this will significantly decrease the amount of files to be transferred. In other words, it is going to decrease the bandwidth. So as a rule of thumb, whenever you use Rsync, make sure you use the Z. This will become a second nature to you, and optionally use the V, because V is going to give you a detailed output, a more detailed output of what is being copied. And -r, we are going to replace it later with another option that is more comprehensive, but let's just stick with -r for the moment. Going to click enter, and as you can see, in less than a second, all the files were transferred. They were transferred in this directory that we have just created on our desktop, which is backup. If I double click on backup, I'm going to see that I have here all the directories that happen to be inside simple PHP website. If I go to, let's go to home, and I'm going to see that I have simple-php-website. These are the very same files that were there. Now, let's say that I'm going to delete all those files from the backup directory on my desktop. Let's go again to backup. I'm going to select all, and I'm going to delete those files. Okay. Gonna get back to my command line, and this time I'm going to remove the trailing slash from the source. So I'm going to copy or sync simple-php-website and remove the slash at the end. If I click enter now, notice what happens. Rsync created a directory for me under backup, and it's created this directory simple-php-website, the same name of my source. If I double click, I'm gonna see that I have my files here. So this is a very, very important thing to watch out for. I've seen many people forget or just ignore adding a slash at the end of the source, and to their surprise, if they are, for example, syncing local websites with a remote one, let's say, for example, that this is your web server, and imagine what will happen if you find yourself creating a child directory inside your main directory containing a copy of all the files that are in the main directory. Of course, this is just a big waste of time and effort. You will have to delete this directory and start all over again. So again, be aware of this trailing slash at the end. The most common use case of Rsync is to synchronize files between source and destination directories, just the files that happen to be under the directory that you are syncing. So make sure that you always use a trailing slash at the source and at the destination. So that is the first use of Rsync. However, if we have a look here, let's go to desktop, and I'm just gonna close those directories. I'm gonna open a new terminal window, just like that. I'm gonna open both of them because I want to show you something. Okay. Now, if I go to PHP simple website or simple PHP website, I'm gonna ls-l. As you probably know, ls-l is going to give me the long listing of the files and directories. Those files have this timestamp 16.09. They've been cloned today at 16:09, which is 4 p.m. Let's look at the backup directory at our desktop. On the other hand, see the timestamp. You're gonna see that the timestamp is different. Although it's the same date, it's December 22. However, look at the timestamp, the hour and the minute of the file. you're gonna see that it is changed. Here it's 4:09 p.m. and here it's 4:15. This reflects the time where those files or when those files were added rather than the date of the original file. Sometimes this is the intended behavior. Sometimes you may want to reflect that those files are new, so they need to have this new timestamp that reflects the date of their creation or the date of their copy. But most of the times you may want to preserve everything that is related to the file, even its timestamp. So you want to preserve the ownership, you want to preserve the file permissions, you want to preserve also the timestamp. If you want to do that, you will have to use a very common rsync option. Let's have a look again at the rsync command. And now we are going to use the A option. So instead of R, I'm going to use the A. So it's ZVA, or as it's more commonly referred to, AVZ, like this. A stands for archive mode. The archive mode will combine several options of rsync together. It is going to combine the recursive mode. It is going to preserve any symbolic links that happen to be inside this directory. So for example, if I have here a symbolic link that is pointing to another directory or another path inside this directory, this is going to be preserved. It is going to preserve ownership and permissions, and it's also going to preserve the timestamp. So let's see what happens if I go 2 steps back from here, or 1 step, and I'm going to remove simple PHP website, and I'm going to use this rsync with our new option, which is -A. I'm not gonna forget to add the trailing slash as we just mentioned a few moments ago, and I'm going to click enter now. Okay, now if I get inside simple PHP, of course it's now inside backup at the root directory, and have a look here at the timestamp. Again, let's have a look at simple PHP. Now notice that the timestamp here is the same, 1609, 1609, it's the very same. So let's clear the screen and let's say that I want to change the ownership of one of the files. Let's say functions.php to be owned by root, for example. Let's say let's make this directory or file owned by a user that is called John Doe, JDoe, for the user, JDoe for the group functions.php. Now if I run our sync command again, notice there the difference. I will need to run it using the root user, because in order to change the ownership and permissions of a directory or a file, you need to be root. So I need to use the rsync command here as root in order to change the ownership of the file on the destination directory. So let's first ls functions is owned by Ahmed, and Ahmed, this is the destination. I'm going to run rsync again, and notice here what happened. Functions now is owned by JDoe for the user and JDoe for the group. And if you change it, the permissions in here, and run rsync again, you will notice that they are changed here. One last thing before I close this lesson is notice that when I ran rsync again, a very interesting thing happened. No files were transferred. No files were transferred again. Rsync intelligently determined that the files that it is about to transfer to the destination directory already exist. It does have a config.php, it does have a content directory, it does have a function, an index, a readme, and a template directory on the destination with the same files that are here, with the same files, with the same timestamp, with the same owner, and so on. Perhaps only the functions file has had a different owner and group, so it just changed the ownership of this file on the destination, but no files were transferred. This is very, very efficient, because if you are working on this web application and you happen to change only 2 or 3 or 4 files, you needn't transfer the hundreds or maybe thousands of files that you have on your local directory to the destination directory where those files already exist there. You will be wasting precious bandwidth and of course precious time and effort. So, as you can see here, rsync is a very powerful tool when it comes to backing up files and directories on your local system. In the coming lessons, we are going to see more and more examples of rsync, but when using it on a remote system. So Until next lesson, take care. Alright, so in the previous lesson, we have seen how we can use Rsync to backup files or to transfer files from one location on your local file system to another on the same machine. And if you are wondering why I'm using Rsync instead of copy, you're gonna see that Rsync provides several advantages over the simple copy command. Perhaps the most important of which is that it only transfers files that have been changed or that are missing from the remote directory, in addition to other advantages that we are going to see when we explore the rest of the features of this amazing tool. So in this lesson, we are going to start using Rsync to upload files or to backup files from your local system to a remote one. And the remote one is going to be our CentOS machine. Remember from our previous section, we installed two machines in this lab. One of them was Ubuntu and the other was CentOS. So let's have a look at the IP address that we currently have on this machine. We have the IP address that is used to connect to the internet, which is the NAT. We're not gonna use that. We're gonna use this one, 192.168.56.101. This is the local IP address that is connected to the lab. Now I'm gonna have a look at my CentOS machine. Okay, and let's open a terminal here. IP DDR, okay. And here again we have the IP address that is local to our network. It's 192.168.56.102. So I can use this machine as my destination. Perhaps this will act as our remote web server or the remote backup repository for our files. Let's create a directory. I'm gonna call it backup. It will reside again under the desktop, just as a way of viewing the files graphically using the Nautilus File Explorer. So let's get back to our Ubuntu machine. Okay, use the SSH command to log into the remote machine, 192.168.56.102. Okay, I'm gonna press yes, enter the password. Okay, as you can see here, let's clear the screen. I have two machines. This is my local machine and this is my remote machine, CentOS. Okay, so what if I want to use the rsync command to transfer files from my local system to my remote one? Simple. I'm gonna use the same command that I've used, and I needn't use sudo because I'm not gonna change any I'm not gonna change any file permissions. And all what I need to do now is add the following before the destination directory, 192.168.56.102. This is the IP address of the remote machine. And then I'm going to add a colon. And a colon here separates the IP address of the destination or the host name if you are using a DNS or if you are using the hosts file to resolve host names to IP addresses. Of course, you can use a host name here. I'm using IP address here, but it won't make a difference. And I'm gonna use a colon at the end, followed by the path to the destination directory. I can add a shortcut here, which is the tilde. And the tilde is a shortcut in Bash for the home directory of the user. Okay, so I'm gonna add slash at the end, slash after the tilde. Just let's widen this a bit. So the IP address followed by a colon, followed by the tilde, which signifies the home directory of the user, followed by just the path relative to the home directory. So imagine that this tilde is replaced with /home/Ahmed, which is the home directory of the user here, then desktop, then backup, and of course I did not forget to add the trading slash here and here. Okay, now watch what happens when I press enter. It's going to ask me for the password. It is going to perform an SSH connection with the remote machine the same way I did here. So let's add the password. Okay. It transferred the files to the remote machine. If I have a look here at desktop, ls-l, Okay, and as you can see here, we have the files inside. Notice here that functions.php is retaining the original username and group. That is because I did not use sudo during the transfer process. Okay, so as you can see here, it is very easy to transfer files between my local machine and my remote one. Now let's say that I changed one of those files. This is the beauty of using Rsync over other traditional ways of transferring files, like SCP for example. I'm gonna go inside and I'm going to go to config.php. I'm gonna make any change. It doesn't matter what, any change. Let's say about us here, I'm gonna change it to be about me, for example. Save. Go one step back. Issue the same command again, rsync. Enter the password. Okay, notice what happens. Only config.php is uploaded. The rest of the files, Rsync determined that they have not changed, so accordingly they won't be uploaded, they won't be transferred. So imagine the amount of bandwidth and time saved by using such a command. Well, let's go inside and let's make sure that our config.php file reflects the changes that we have just made. Okay, about us here is changed to be about me. Okay, now let's say that for some reason or another you made a mistake and you deleted a file from your local machine, from your local file system. Let's say that inside simple.php I accidentally did something like this. readme.md has been deleted. Now it does not exist. Although readme.md might not be the most important file of your web application, it's just a readme. However, you may want your directory to be intact. You may have some important information inside this readme.md that you don't want to be lost. So you can restore this file and restore any file that has been deleted or changed by simply reversing the process. Instead of uploading the files and directories from your local file system or from your local machine to the remote one, you can do it the other way around. So I'm gonna get back to the rsync command, and using the very same syntax that I used, I'm just gonna change the order of my arguments. So I'm gonna have the source 192.168.56.102, which is the CentOS machine, and this is the source path, and the destination path is going to be simple-php-website, just like that. So what I'm doing here is that I'm downloading any files that have been changed on the remote machine to my local machine. Pressing enter, I'm going to enter the password. Okay, and I have here readme.md, and I have here also functions.php failed. Okay, let's use sudo. Maybe that is because of the changed permissions. Okay, it's gonna ask me for the root password. I don't want to do that, so watch what I'm gonna do here. Because I'm using sudo, it is going to automatically use the root user to connect to the remote machine. That is because if I did not add a user before the IP address, it is going to use the default user that is using the command. In our case, it's Ahmed, and fortunately enough, we have a user of the same name on the remote machine. But if I'm using sudo, it's gonna use root, so it is gonna try to connect to the remote machine using the root, which is not our intended behavior. So I'm going to add Ahmed as the username, and I'm gonna add the @ sign before the IP address to indicate that this is the user that I want to log in with to the remote machine. Pressing enter, now it's asking me for Ahmed. Password. Okay, now we do not have any errors. And if I ls-l simple PHP website, I'm gonna see that I have readme.md successfully restored. So as you can see here, I can use rsync both to upload files from my local system to my remote system or to my backup system on a remote machine, and I can also use it to restore files and directories from the remote machine to my local one. And notice here that if any files got changed on the remote machine here and I used the rsync command the way I used it here, it is going to transfer those files back to my machine. It's going to overwrite the files on my local machine here, so be aware before using rsync in that matter. That brings us to the end of this lesson. In the coming lesson, we're going to see more tips and tricks that we can use with the rsync command. So until then, take care. In this lesson, we are going to see some of the slightly advanced SSH connection tips and tricks. This lesson is not specifically for rsync. It is rather for the SSH protocol on which rsync is based. It is very useful for you if you want to automate your rsync file operations. So let's get started. Now, if you have noticed in the previous lesson, when we used the SSH command, we were forced to enter the password whenever rsync is used. So what if you want to run rsync in an unattended mode? In other words, you want to run rsync, let's say, on a scheduled job basis. You want to ensure that every day at midnight, for example, all the files on your local system are synchronized with the remote system, or maybe the other way around. You want to ensure that anything that has been changed on the remote machine is reflected to your local machine. So in order to do that, we need to be able to connect to the remote machine without using a password. In other words, we want to use the public private key to connect. Public private key is an SSH way of connecting, but without using a password. You use a key, which is called the public key. You transfer this key to the remote machine, and this key has another part called the private key. The private key always stays at your local system or your local machine, and when you attempt to connect, you show the remote machine the private key that you own, and the remote machine takes this private key and it compares it to the public key that it has using some crypto mathematical operation, and if they both match, it is going to grant the connection for you. It's going to accept your connection, otherwise it's going to deny your connection. So let's clear the screen and see how this can be done. So the first thing you need to do is use the SSH keygen command like this. SSH-keygen is going to generate the public and private key pair for you. Press enter. The file where you want to save your key is by default, this is a private key. It's by default inside your home directory in a hidden directory that is called .ssh. The file by default is called id_rsa. Of course, all this can be changed. However, it is recommended to leave it at the defaults. And here you are prompted to add a passphrase. A passphrase is an added layer of security for your private key. If you added a passphrase here, you will have to enter this passphrase whenever you want to use your private key. But of course, since we need to make an unattended rsync connection or SSH connection, we will not add a passphrase. So I'm going to press enter to leave this empty. Press enter again. And now the file or the file pair has been created. If I have a look here at .ssh, I'm going to see that I have id_rsa, id_rsa.pub. And notice here the permissions of the file. It's going to explain everything for you. id_rsa because it is the private key. It is only readable by the current user, while the id_rsa.pub, which is the public key, is readable by the user, by the group, and by anybody else on the machine. Okay. So what I need to do now is to use the SSH copy ID, and it is going to copy this ID to 192.168.56.102, which is the IP address of the CentOS machine here on the right. And what this command is going to do is that it is going to go here to .ssh directory inside the remote machine. Of course, this is inside the home directory. Okay, it is not created yet. It is going to create this .ssh directory, and it is going to add a file that is called authorized keys, a file similar to this one, and it's going to add the contents of id_rsa.pub inside this file. So let's press enter. Okay, enter the password. Okay, now if we have a look here at .ssh, gonna find that this directory is now created. Inside it, you will have authorized keys. If you display the contents of this file, you're gonna see that it has this crypto looking group of strings and numbers, special characters, and so on. This is exactly the contents of this file. .ssh id underscore RSA dot pub. Okay, this text is exactly the same text as this one. So because I did that, if I try to SSH now to 192.168.56.102, which is the IP address of the remote machine, press enter, I'm going to be inside the machine as you just seen without having to enter a password. Now I am logged in at CentOS. Okay, I need to do this the other way around to be able to log in from my CentOS machine to my Ubuntu machine, again without using a password, and that is to reverse the operation when you want to download files instead of uploading them. So in order to do that, let's do the same steps that we have just did. SSH keygen, enter, 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 just very basic stuff. Then SSH copy ID, and I'm gonna give it the IP address of my Ubuntu machine, which is 101. I'm gonna accept the certificate the first time. I'm gonna enter the password. Okay, and now if I try to SSH to 192.168.56.101, I'll be inside the Ubuntu machine. Sorry, I entered the IP address incorrectly. I'll be inside the Ubuntu machine without having to enter a password. So now I have completed the first step of the operation. Now if I want to use the rsync command again, let's remove the sudo. And of course it's not gonna transfer any files because none has changed, but I'm just gonna show you that it will not ask me for a password no longer. Okay, as you can see here, rsync has successfully connected to the remote machine, compared the directories and the files that are available on the local host or on the local machine with the ones available on the remote machine, and because it did not determine any changes, nothing was transferred. So let's make it transfer something. Let's change anything in functions or PHP, for example. I'm going to, okay, let's not change the functions. Let's change something that is not destructive. Again, let's go to the config.php, and let's say that I'm gonna change products to just product. I'm gonna remove the S, any change, and I'm gonna get 2 steps back, 1 step back, and I'm going to rsync again. This time again from my local machine to the remote one. Okay, and of course config.php was transferred because this file had changes. And notice here again that when we transferred files from the remote machine to the local one and from the local one to the remote one, in both operations we were not asked for a password. So you can very easily take this command just as it is, like that, edit, copy, and do a very simple cron tab job. Okay, gonna add, this is going to run every day at 12 o'clock. Okay, and going to paste this command just like that. Okay, so as you can see here, every day at 12 o'clock exactly, all the files that are inside simple-php-website, let's just add the complete path, because cron job does not care or does not know where we are standing right now in path, so you have to enter the full path. So it's going to transfer everything that's inside /home/ahmed/simple-php-website to the remote machine, the CentOS machine, under a directory that is called backup, that happens to be under the desktop of the user. Okay. This is going to run, and it's not going to ask you for a password, so this is an unattended way of running rsync. Now let's have a look at one of the advanced uses of rsync over SSH, which is that when you want to connect to the remote machine over SSH, but without using the default port, which is 22. Now, as you probably already know, SSH runs on default port 22. If you go to /etc/ssh/sshd_config, enter the password, of course, you're gonna find that by default, you listen at port 22 here. This is where the SSH listens. But what if I change this to be 2222? And this is sometimes some system administrators prefer this, so as a way of obfuscating the settings of a critical service like the SSHD. So they change the default port from 22 to another port like 2222, for example, so that if somebody is going to attack your system, he or she is going to take some time to determine the port on which SSHD is running. So what if you have this situation for some reason or another, and you have the SSHD running on a different port? So I'm going to sudo service SSHD restart in order to reflect the new changes. And of course, this session is going to terminate once I do that. We had a problem with SE Linux. I had to stop it in order to make this change. Okay, and now we are listening at port 2222 for the SSH. If I exit from this session and I try to connect again, this is the plain old SSH command. I'm not using Rsync yet. I would have to specify the port by using the -p option like this. SSH-p 1234, enter. Okay, and I had to open the firewall rule at the remote host in order to enable port 2222. That's why I was receiving those errors. Now let's try to connect using that port. Okay, and we are inside. So now let's say that we want to use the rsync command again, but this time we want to use the new port. Simply enough, all what we have to do is just add -e, and -e will allow you to enter arbitrary SSH commands. Or in other words, you can add whatever options a typical SSH command is going to use. Let's say, for example, in our case, we want to add SSH-p 2222, just like that. Pressing enter. Okay, and as you can see, rsync is working as expected, although we have changed the SSH port to be another one, which is 2222, and yet we were able, by using this option, we were able to make the rsync command run over the modified port on the remote SSH daemon on the remote system. And of course, the same thing can be done the other way around if we use the same option by making the remote host the source and our local file system or our local host at the destination. It will work the same way. In the coming lessons, we are going to see some more advanced features of rsync. We have already now covered the SSH protocol and its different tips and tricks. Let's have a look now at other rsync advanced usage. So until next lesson, take care. Hello everyone and welcome back. Sometimes you may want to transfer a large file from the source to the destination. And over the network, of course, especially if you are transferring it over the internet or over a wide area network, this file might take a considerably long amount of time to complete. And it might be useful for you if you were able to view the progress of that file, the speed at which this file is being transferred, and whether or not there are any bottlenecks, or for example, if the transfer operation is being halted for whatever reason, then you might want to check with your network team, or you might want to check for any connectivity problems with your remote host. In all cases, rsync gives you the --progress option for that reason. Now, before we go ahead, let's go to simple PHP, and I am going to create an intentionally large file by using the dd command. dd is a Linux command that is used to copy files or copy data at the block level. So I'm going to use dd-if for input file is /dev/0. I'm just going to create a file that is full of zeros. of equals data bin, for example. Okay, and count is, for example. Okay, this has created a 1 GB file, approximately. Now, if I want to use the rsync command as before, I'm going to add --progress, just like that. Pressing enter. As you're going to see, in the data.bin, because it is a considerably large file, it is going to give you a nice progress bar with the speed, the ETA, the percentage of data completed, total amount of data transferred so far. Okay, and it's done. Of course, this is as we said, very, very useful when you are transferring large amounts of files between the source and the destination, especially if the destination is on a remote machine over the network. Now let's delete that from here. Okay, now this file has been deleted from the source, but it is still available at the destination. As you can see here, data.bin is there. Now what if I want this file to be deleted automatically whenever I do an rsync command? This can easily be done by using the -- delete option. So I'm gonna delete the progress here, and I'm going to use -- delete, just like that. Press enter. Okay. It saw that you have a file at the destination that is called data.bin that is not present at the host, at the source. So it intelligently deleted that file. Now if I ls-l data.bin again, it is not there. So that is a very useful way of ensuring that only the files that are available on the source are being synced with the destination. And sometimes you may be interested in doing the reverse. You may want to update only the files that exist on both the source and the destination, but any other files you don't want to create. So let's clear the screen, and let's again create our data file, data.bin. But this time I'm interested in syncing all the files that are on the source or on the local machine, but not data.bin, since it is not, or it does not exist on the destination. This time I can use the rsync command, and instead of using the -- delete, I can use -- existing, just like that. -- existing will ensure that only the files that are available on both the source and the destination are going to be synced. Any new files created on the source are not going to be transferred as long as they are not present on the destination. If I click enter, okay, nothing has been copied, although I have here data.bin that is not available here. But because of that, because of this difference, this file has not been transferred. This is very useful in scenarios where you, for example, you have log files that are constantly created on the local machine, and those log files need not be transferred to the remote machine. They need not be backed up. You only want to back up the files that have been synced before between the source and the destination. Any new files are not of great importance. These should not be backed up. So you can use this option -- existing to achieve that behavior. Now, what if you are just interested in showing the difference between the source and the destination? Let's say, for example, that you have those two directories and you don't want to sync them as much as you just want to have a look at the differences between them. So let's make a difference here. Let's have a look again at the files that we have. Again, let's make a difference in the README file. And again, let's change that to be GNU. That's a change on the readme.md file. And in here, I'm going to change the config.php file. Let's make any change that you want. Let's say, for example, I want to change this from capital C to small c. Save. And now I'm interested just in knowing what has changed between both directories. So I can run rsync again the way I'm used to. Let's omit this existing flag, and I'll just add the I option at the end. The I option is going to just show me what has been changed between the source and the destination. If I click enter, okay, and now I have some indication of what has changed. I clearly can see that I have a config.php file and a readme.md file. But I also have some symbols here that give me information about what exactly has happened. For example, I have the F here. The F means that this is a file, not a directory. If you have a look here at the D, this is a directory. It's just showing me that I have a change in the directory. Of course, the root of the directory has been changed. That is because I have files underneath it that have been modified. So F is for the file. T represents the timestamp. So the change in both files have been a change in the timestamp. This means that this file has been modified in a more recent time than the original one. Also, the README has been modified accordingly. And in other words, the content of those files has been changed. This is what the timestamp means, or what the T means. But I also have some other symbols that may be of some significance, like for example the S. The S means that the size of the file has changed, not only the timestamp but also the size. And the O and the G. The O stands for owner and G stands for group. This means that the owner and or the group of the file has been changed. So in our specific example here, the only thing that changed is the T, or the timestamp. And the greater than sign here that you see means that those files needs to be transferred from the remote host to the local one in order for the files to be in sync. Of course, I have did two changes, one on the local machine or the local host and the other one on the remote host. So I have two files that are not in sync. Rsync is suggesting that I have both files transferred from the remote host to my local host in order to keep all files in sync. Now, last, let's have a look at some powerful feature of Rsync, which is the ability to include or exclude specific patterns of files. Let's clear the screen in order to see how this can be of use. So let's say, for example, that inside simple-php-website, you have, let's have a look, maybe we have some files that are not ending in PHP, unfortunately. So look at the template. Okay, seems that all the files here are ending in .php, so let's create some of our own. Let's create a directory that's called images, for example, and inside images I'm going to quickly create a number of files that are all ending in the famous .jpg format. So for I in 1 to 10 do touch file. So what this basically did is that, what this basically did is that it created a number of files. Just omit that file one because it was created by mistake. Now those files are all ending in JPG. Let's pretend for a moment that these are image files. So we have the typical files or the PHP files ending in .php, and we also have the images ending in .jpg. Maybe you are interested in transferring only the PHP files, the ones ending in .php, to the remote machine or to the remote destination. And when I say remote, I'm not specifically referring to the remote machine. All those options, all the Rsync options that we have studied so far can work whether you are transferring files to a remote machine on somewhere on your network or to your local machine on another file system. They are going to work just the same. The only difference is that you are going to add the IP address of the destination instead of adding the file path of the destination, but all the options are the same. So let's say that I want to transfer only the PHP files, for example. I don't want to transfer the images. So let's have again our rsync command. Of course, let's go one step back first. Okay, and here let's omit the I, and I can use -- include like this. Then I can use the wildcards to fine-tune the types of files or the file names, not only the file extension. You can also use it to include or exclude file names that are going to be transferred. So in my case, I'm interested in including .php files, and I can also use -- exclude together with the -- include to also exclude other files. This means that I am going to transfer all the files that end in .php. If I click enter, okay, nothing was transferred because of course the PHP files have been synced before between this directory and the remote one or the destination one. But watch what happens if I go to images and I also touch a file, let's say file 11.php. So now I have those files .jpg and one file only in PHP. Now let's clear the screen and let's modify this and specifically tell Rsync that I want to exclude extension .jpg. So only transfer PHP and ignore JPG. If I click enter, as you can see, it is going to transfer the images directory as it is, and it is going to transfer only file 11.php. If I have a look here, I do have a directory that is called images. Inside it, I have file 11.php. I can do the other way around. I can ignore anything that is ending in .php and only transfer JPG files. Of course, this is just going to sync the directories because I already have all the PHP files there. But I'm just showing it here for demonstration. So, okay, it's transferring all the JPG files. No PHP files were transferred. Like this. That brings us to the end of this lesson. In the coming lesson, we are going to have a slightly different topic, which is the streaming options in Linux, how to stream videos to players or devices over your network using VLC on Linux. So until next lesson, take care. Alright, hello everyone, welcome back. In this lesson, we are going to study how we can use the VLC, famous video player, in order to stream media from our Linux machine. So let's get started. So by default, VLC is not pre-installed with Linux distributions. And if you want to install it, you may want to add some repositories to your default repository list. So let's have a look at our Firefox browser. Let's launch it. See exactly the steps that are needed. And I'm going just to go to videolan.org, which is the website responsible for distributing the VLC. And have a look here at the various URLs, the various platforms that VLC supports. So I'm going to click on the Linux icon. Okay, and inside here you have different options of installing VLC on GNU Linux. I'm going to choose Red Hat Enterprise Linux because this is the closest to CentOS. You can also choose Fedora. And these are the steps that are needed to install VLC on the CentOS 7 or Red Hat Enterprise Linux 7. So I'm going to just follow those steps. I'm going to copy this, open a new terminal. Okay, I'm going to sudo su- so that we are working as root. Paste the first command. The first command is going to install the EPEL repository. It provides some of the third-party tools that are needed by most CentOS or Red Hat Linux distributions by default. It's got an RPM installation, so we're gonna use that. We're going to also install the RPM Fusion repository, which is another repository that provides third-party tools. Both of them are needed for VideoLAN installation. Once both of them are installed, you can just use yum as it is stated here, dom-shy install VLC, written right here, VLC and VLC-core. Gonna install both of them. Okay, now VLC has been installed. Let's minimize this window and that one. I'm gonna use the graphical interface now. In the sound and video, you're gonna find that you have this icon of VLC media player. Let's open it. Click continue. And here you have many options for playing video, but we are here interested in streaming it. Streaming, if you are not aware of this term, refers to using some source like a file, a video file, for example, or an audio file, or even a network resource, like if this media file is located on some remote location, and use a software like VLC or other streaming software to provide a URL for playing this video or this audio on a remote machine. Just like when you browse to YouTube for playing a video, for example, YouTube has a streaming server located somewhere, and this streaming server has a file, a video file, and it reads data from that video file and it streams it over the internet for you to watch. So that is roughly what we are going to do now using the VLC media player. So click on media, and near the end of the menu you're gonna see stream. You can also activate this option by using Control S. Gonna click on that. First thing you're gonna do is that you are going to choose the file which you are going to use for your streaming. I have already downloaded a file, a free video file from the internet. It's located on the desktop. Okay, I'm gonna choose that file. Optionally, you can add a subtitle file if you want to add subtitles to your video. and then click on stream. Okay, so this is the source. Let's click on next. The second option here is how you are going to play this file. You have a number of options that VLC supports. Like for example, the HTTP, you can either stream it to a file, you can stream it to an HTTP over the HTTP protocol, over MMSH, over RTSP, UDP, and other streaming protocols. I'm going to just choose the simplest one, which is HTTP. And you have to click add. Some people just forget and they just choose HTTP or whatever protocol they want and just click next. That will not stream the video. You'll see that the video is not being streamed, and unfortunately VLC will not warn you about that. So if you want to stream that using HTTP or whatever protocol here, you will have to click on the add button after you choose your protocol. And I'm gonna choose the port. I'm gonna leave it at the default port 8080. But before I go ahead, I will have to make a very important change here, which is to change the firewall rules to allow port 8080 like this. I'm gonna type firewall-config on CentOS, type the password, and I will be inside the firewall GUI. Click on ports. As you can see here, I added the 2222 TCP protocol for the previous lessons, if you remember, when I had to use a different port for the SSH protocol. Okay, let's add the 8080 port. It's a TCP, and click OK. Close that. That is mandatory if you want to allow anybody to view your stream from outside this machine. Okay, now let's click next. And here you can choose to transcode your video. Transcoding basically means changing the codec in which the video is encoded to another codec. This is just, for example, if you this file, for example, is ending in .mov or movie. This is normally played by the QuickTime application. You can change it to, let's say, for example, OGG, which is another format. It just changes the format of the video so that it can be streamed in another format. Can activate it or deactivate it. I'm going to activate it, and I'm going to transfer the video to the OGG format to be streamed in that format over the network. Okay, I'm going to click next and have a look at this stream output. It can be used with VLC if you want to use VLC on the command line. If you want to use VLC on the terminal, like here for example, VLC allows you to use it on the terminal and add this string to the end of the command in order to stream from the command line. So you can have a copy of this if you want to, in order to use it with VLC on the CLI. And finally click on stream. Okay, now it's streaming. Of course, it's showing you nothing on this screen because it is streaming over the network. I'm going to click on this icon in order to repeat the video because it's rather short until I open my VLC player. I'm gonna just minimize this window, and I'm going to bring up my VLC player. This is on my host on my Mac machine. And I'm going to click Command N or Control N if you are on a PC. Type in the IP address of the machine. Don't forget the HTTP at the start and 8080. And open. Okay. As you can see here, this is the video that I am streaming from the remote host. It's a video of a turtle, as you can see. And it is streaming through the VLC player. That brings us to the end of this lesson and to the end of this section in Project Eduonix by Eduonix. My name is Ahmad. I hope you enjoyed this section, and see you next.